Test, test. Mic test. Hello and welcome. It is, what is it, Monday? It's Monday. How are we doing? Tonight we're doing something a little bit different. Tonight we're going to be live streaming on multiple platforms. We are live streaming on Twitch and we are live streaming also on YouTube. So my YouTube channel is youtube.com/IQ Workshop, and my Twitch channel is twitch.tv/IQ Workshop. So losing track of days. Hey Kazarus, welcome in. Yes, I am. This is a first for me. I did a test stream last week, where I was live streaming to Twitch and a private YouTube stream. That all went well. So this is the first public broadcast multi-streaming on both platforms. So how you doing, Kazarus? For those of you who are watching on YouTube, if you see me responding to a chat that you can't see, that is a chat that's taking place over on Twitch. And equally, if you're on Twitch and I'm responding to a question that nobody in Twitch has asked, I'm answering somebody on YouTube. Hopefully that makes sense. It's new for me. So let's see how tonight goes. So tonight, I'm going to be working on a new project. Basically, we're waiting for components for the Lumen PMP to arrive. Last live stream that I did on YouTube, we were building a Lumen PMP pick and place machine. We got the base of the machine completed, and I now have all of the components printed for the mechanical assembly. We're just waiting on some linear bearings to arrive through the post, so fingers crossed we can get that. Yeah, I think a chat repeater, Kazarus, is going to be the way to go, to make sure we get chats on YouTube and on Twitch and vice versa. I'm going to refrain from putting chat up on screen as an overlay, because that's actually in breach of Twitch's terms of service. Twitch have got a rule whereby if there's something offensive that comes up on the screen, the streamer is held accountable. Now, on Twitch, there's elements where you can moderate and kind of trap and capture that sort of chatter, should that come through. But if something comes in through YouTube and gets presented on Twitch, it would be a violation of Twitch terms of service, and it's not something the Twitch moderation system can handle. So for that benefit, or for that reason, I'm not putting that up on an overlay. So the stream that the project that I'm going to be working on with this stream, I am building a control system for my lights. for guys watching on Twitch, you already know that I have already built a light system that enables me to control my streaming lights, and it helps me get my stream up and running as quickly as possible. Or if I'm recording content for YouTube, it helps me get my workstation all, you know, ready to go. The problem with it at the moment is that the wires, so I've got my key light over here and I've got my fill light over here, and the cables actually run to a set of mains voltage sockets which are controlled by a relay, and that relay system is just up here outside above my main light. And I've hooked this into Home Assistant, so my Home Assistant can control them. But I also have it controlled via Alexa, so I can make a command and get my Amazon talking device to turn my lights on and off. And I'll quickly demonstrate that now. So, Alexa, turn streaming lights off. And there we go, right? And Alexa, turn streaming lights on. So that works, but what I want to do is build a module that can connect to my home setup and take control of these lights and mean that I can cable manage things a little bit better. So I'm kind of diving into part of the process that we're going to be talking about on stream. So let's get into that now, shall we? Let us fire up this little dude ticky here. Yeah, Restream bot can do the chat. It's just getting it set up properly. Right, okay, so I'm going to pop this by here, and now I'm pop it down here. And if I jump to this scene, okay, that should have fixed that. See, there was me getting all excited that I've set up some new scenes for this. But anyway. So, the project is a low voltage control module. So we're going to set up some project objectives, and then we're going to put in here some things that we need it to do, right? So let's look at some project objectives. So let's have a look. So number one is it needs to accept a range of voltages from, I don't know, let's say 4 volts up to 20 volts. And that gives us a range of devices that we can actually control with this device. Oh, look at that. Let's fix that. All right. Okay, so you can set the range of voltages between 4 volts and 20 volts. The second thing is I want this to be flexible. So I want to be able to control up to 4 devices. Now, I need to be clear here. The devices that we're going to be controlling, they have to have pretty much the same input voltage ranges or have to be voltage tolerant. So if I've got a device that's being powered off 20 volts, if I have another device that's powered off 5 volts, that's not going to work out well for the 5-volt device. Equally, if we've got a 5-volt device as the primary and we've got a 20-volt device, it's going to undervolt. So we need to make sure that we align. We have to have parity in terms of the voltages that this is going to be able to control. So I want to be able to control up to 4 voltages. And let's just specify of same voltage. Now, is that going to fit on my page? It is. Cool. All right, same voltage. Okay, 3. What do we got here? So it needs to connect to Home Assistant. So let my Home Assistant control this. And we also want to be able to connect it via voice. And that's going to be part of my configuration, right? I'm going to have a pretty unique or bespoke solution in terms of how my voice control works. But we'll cover that as we get to it. Okay. So we're going to be literally prototyping this whole thing out from scratch. So I'm going to be using a microcontroller. How am I going to word this? So that's a project. This is objectives. Okay. So we're going to use an ESP8266. So yeah, we're going to use an ESP8266 controller. We're going to use a logic level MOSFET to do the switching. I guess we probably want local control. Yeah, we do, actually. Not I guess. We want local control. What do I mean by that? So when I talk about local control, I'm talking about the ability to press a button on the device locally to power it on, off, etc. So we need a series of buttons as an input that will then trigger the switching of the device itself. Now, in this instance, I'm going to make it fit a battery module. Board needs to okay, so it needs to sit inside a battery module. And what am I on about with that? I am on about this. So this is the battery module for the lighting system that I've got. I've got two, I think they're, yeah, 6-inch I've got two 6-inch LED panels, and it has these 7 volt, a 7.4 volt batteries. And I'm going to make an analog or fake battery that our circuit board is going to sit inside, and we'll have a couple of buttons across here that we can press and turn on the device accordingly, right? And we could potentially even add some LEDs. In fact, we're going to, because we can. We want some LED indicators to specify when a particular device is on, and we'll align those with the buttons, I think, so they're next to each other. And that'll help us figure it out. Now, bearing in mind, with the setup that I'm going for here, is that the device is going to be controlling a single light in this instance. So we're not going to populate this board to its full extent. We're not going to put 4 MOSFETs on. We're not going to place 4 buttons, 4 LEDs. It's going to be 1 MOSFET, 1 LED, 1 button for this setup. But building this in gives me flexibility of using this for other things. So, for example, I could change this out to be a 12 volt fan controller so that you can press the buttons and fans come on, not lights. I can control up to 4 fans. You see where I'm coming from? So if you're in chat, please sound off as I'm working away. Feel free to question me. On what I'm doing. Question me why I'm going about things the way I am. As I say, we're live streaming on Twitch and YouTube. And yeah, if you see me answering a question that hasn't been typed into your chat, I'm talking to somebody on the other platform. So, okay, so we've got LED indicators. What else do we want? We got ESP8266, logic level MOSFET, local control, boards need to fit inside a battery module, LED indicators. Is there anything else we want to add in terms of features? Yeah. Well, last stream, we were building a Lumen PMP. So I'd like, ideally, for this to be able to be put together by the Lumen PMP. So, we want it to be Lumen PMP compatible so it can assemble it. What does that mean? So I think, from my understanding, is that we need to ensure that we've got something called a fiducial on the circuit board. A fiducial is essentially a reference point so that when we program the assembly job, the Lumen can actually figure out where the board is in 3D space, in XY on the build platform. We need a minimum of 3 fiducials to get an accurate calibration of where the unit is. So let's make sure we put in here at least 3. That's the minimum that we need. So the objective, we need to design and prototype a low voltage control module that is capable of switching loads ranging from something quite small to something a bit heavy, right? We need to accept a voltage range between 4 and 20 volts. We need to control up to 4 devices at the same voltage ranges. We need to be able to connect the Home Assistant, and we need to have voice control of the devices as well. Key attributes are that we're using an ESP8266 module. We're using a logic level MOSFET to do the switching. We want local control, so we want to add buttons. We need the board to fit inside a battery module so that it can fit onto the back of the light itself. We need LED indicators as a visual display as to what is actually in operation. And it needs to be Lumen PMP compatible by adding the fiducials on the board. We also need this to have the power in line, right? So it's going to take power from the device's main supply. So the power pack that I'm going to use to power my lights is going to be what powers this board. So that's the final thing I think I'm going to put in here. So powered by low voltage adapter. Right, so why am I doing it that way? Why aren't I doing what I did before, which is to switch the mains voltage? Well, first and foremost is that I don't particularly want to be messing with mains voltage if I can afford to do so. Gotta love fiducials, right? It means that I can plug in the adapter into my board and then have a fly lead from the board as an output into the device that we want to control. And that will give me everything that I need in a simple combined package. And that's ultimately what we want, right? Something that's uncomplicated, easy to set up, has multiple uses, and is going to give my lighting system a very minimalistic look in terms of cable management. Like, cables are everywhere at the moment. I'm going to be able to route my cables down underneath my desk, cable train them, and I'm not going to have to worry about any of the control software because it's currently being driven by the mains voltage. Right, so now we've got our project. Let's get our parts together so we can start prototyping. So I'm going to grab my electronics library. I've got a little box here of all of my electronics components, and I've got a little special box here for microcontrollers. So let's grab that. I'm going to grab my breadboard, and also I'm going to grab my jumper wire setup. We're going to get this working on a prototype board first, because we need to know that the circuit that we're designing is going to work. And there's nothing more annoying than you taking a prototype, try to make it work, and it doesn't. So you want to be able to fail fast. If you can avoid messing with the mains, always go that route. 240 volts to ground through your fingers is not fun. Yeah, that probably sounds something you want to try and avoid, Kazarus. Absolutely. Right, so here's my solderless breadboard. Essentially, this allows me to drop components onto this board and quickly wire up a circuit to Fuck naked! Thank you so much for the reset, buddy. 27 months. It's crazy. 27 months. I can't get over that. For those of you watching on Twitch, that was a subscribe event over on Twitch, which is very different to a subscribe function on YouTube. But if you want to hit the stream, feel free to hit that subscribe button on YouTube or the follow button on Twitch. If you want to help me fund some of these projects, take a look in the description of the respective videos and you have a link to my Ko-Fi to my Ko-Fi link, where you can drop donations if that's something you want to do. So, hey Buck, how you doing? Hope all is good. Okay, so I'm just gonna dive into my microcontroller box, and I've got all sorts of like little goodies in here that we can play around with. So let me just show you what we've got going on in here. We've got all sorts of different microcontrollers. So I've got this is an Arduino Nano. It's a little tiny microcontroller board. We've got ESP32 modules. These are actually quite powerful. These are actually got 3 processors in them. 2 power cores, 1 low power core, and it's actually what is driving my homebrew stream controller. So one of these modules is in here driving that. So we don't want something that powerful, right? Even though they're inexpensive, it would be a little bit of overkill to put that in there. So we're not going to use that. We've got some ESP8266 bare modules. So this is the module that we're going to use in the final version. But how are you going to get it to prototype on this board? It's got no pins. It's got nothing, right? So we'll cover that in a second. We've got some Pi Picos. I got to find a project for these. I bought some to experiment with, and I've yet to play around with them. So let's put all of these components away that we don't need, and let's grab something that we do need. We are going to unfurl one of these. So this is a Wemos D1 Mini. It's a development board and has an ESP8266 microcontroller on board. But it has some additional things on there. It has got all of the pins of the microcontroller broken out to the edges of the board. It also has a reset button, so you can actually restart the device. But it also has some circuitry on here that allows me to program the device easily over USB. Now, we're not going to include a lot of the circuitry that this board gives us. This is for our convenience for prototyping. Once my ESP8266 has been programmed, it's not really going to need the USB functionality thereafter. So it seems pointless to provide all of this circuitry for a one-time use. That's pretty silly. So we'll just use the bare minimum for this board when we design it, and we'll break out some pads for the programming, which we'll be able to use once, and after that, it doesn't really matter. So, okay, so we're going to use that, but you'll notice this also does not have any pins to drop in here. But if we open up our package, let's open up, let's get all of the goodies out. We have these various different adapter configurations. So we can do a bunch of different things with our projects. Flexible. Right, where have we used that process before? I wouldn't like to say Lazarus. I've used it before. The thing you're thinking of. So there's a reason I went that route. Because I knew I could. Right, let's power up my soldering iron because we're going to need to do some soldering. So we're going to place we're going to place these header pins, put them through here, and we're going to solder them. We're going to solder them in place, and it'll make an electrical connection, and we can place it down on our board and get it all up and running quickly, I might add. All right, so while the iron's heating up, let's get the soldering iron, and let's get the camera, the microscope out. And let's jump over to the microscope scene. Let's power up the microscope first. I'm hoping that the microscope is going to power up on screen properly for us, but we'll soon find out. Yeah! Woohoo! It worked. So what you're seeing is a close-up view of our component. So let's get lined up. And what I'm going to do is I'm going to place my components into the breadboard. Make sure that they are nice and parallel before pushing them down. And we're going to use... There we go. We're going to use this as a bit of a template. Let's bring the microscope up a little bit. Sorry for the shaky cam for a moment. Let's get us focused in. Try to give you guys a good view. All right. Soldering irons up to temperature. Let me just grab... Need my solder. I'm currently running at 450. Rhubarb! Welcome in. Welcome in. We're live streaming on Twitch and YouTube tonight. So, yeah. If you're on YouTube, feel free to hit that subscribe button. If you're on Twitch, feel free to hit that follow button. Remember, subscriptions and follows are free. And they really do help the channel. So all support is welcomed. So what I'm going to do here is I'm just going to tack on either side of this row. And all I do is just place my iron on the corner here and let everything heat up. And we'll bring a little bit of solder in. There we go. And then we've tacked one corner. And we go to the other side of the controller, which is just out of shot. And do the same thing over here. Could really do with some solder on my iron to help the heat transfer. Get a bit of solder on the iron. There we go. That'll just help with transfer. Now we switch over to the other side. Oh, thank you so much. Well, on YouTube, we are pushing for the 3,000 watch hours for the basic monetization window. So any watch hours that the stream gets, I mean, is going to help me a lot. So we're currently hovering around the 1,400 mark. So we're around halfway. Just under halfway to the 3,000. Ideally, I'd like to get to the 4,000 for full monetization. But one step at a time, right? That's how you get to your destination. One step at a time. Right. So I've now got all four corners tacked. I'll make it look easy. I am definitely not the best solderer in the world, right? I've practiced and practiced and practiced, and now I'm doing surface mount work. That has helped me incredibly, right? So, but I appreciate the compliment, Rhubarb. Trick is to get the heat into the part and let the iron and the solder do the work. So what we're going to do now is just come through and we're going to just tack each of these. Now, I don't know if that's just me being too close. Yeah, it is me being a little bit too close to the... There we go. That's a little bit better. I do like my soldering iron microscope. It helps a lot with, especially working with small components. The problem that I do find with it though is there's two problems I've got with this setup. The first of which is that it's on a microphone boom arm. So there's quite a lot of shake to what I'm looking at. I started to get used to that a little bit. But secondly, you lose depth of field. Yeah, so, or depth of vision. So with two eyes, you get depth perception. With this microscope, you've got one lens that you're looking through. You're looking at an LCD screen. You lose all depth perception, and it can throw you off when you're trying to do, like, get your iron in. And it takes a little bit of practice to get to a point where you can use this effectively and not be like waving your hands up in the air. Come on. That one didn't want to go. Something's wicking the heat. There we go. Oh, thank you so much, Rubab. Are you watching on Twitch and on YouTube? All right. So if I switch over to the overhead camera now, right? You can see that we've got... Come on, camera, you got one job. Your focus needs more focus. I may actually have to take manual control of my camera's focus here because it is awful. Ah, thanks, buddy. Appreciate you. Okay, autofocus off. Okay, see if I can get you to see this a little better. So if I bring this up, we're slightly zoomed as well, right? And it's a digital zoom. Right, so it's soldered. So we now have our board ready to rock and roll, right? So we now need... Put autofocus back on. So now we need the device that we're going to be switching with. And I picked up some MOSFETs. These are a type of transistor, a special field effect transistor. And these MOSFETs, bring the microscope back in and we can take a look. And this is what microscopes are good for, right? Helps us see things. So this is an IRLZ34N type MOSFET. What does that mean? So the L in this code stands for logic. So it means that I can use a low voltage signal to trigger this device and turn it fully on. There's certain MOSFETs that need higher voltages. So when you try and apply a logic voltage to it, it doesn't fully turn on. It's kind of halfway. and you don't necessarily get the desired result. So with this logic level MOSFET, we know that we can use an output from our ESP8266, which is 3.3 volt logic. We should be able to turn this on without any issues, or any other components for that matter. If we didn't have this logic MOSFET and we wanted to turn it fully on, we would have to incorporate a transistor, and we would turn a regular transistor on, and that would then drop a higher voltage to the pin of the MOSFET to turn it on. So all a MOSFET is a switch that we can control using outputs from our ESP8266. What I'm going to do is I'm going to just drop that MOSFET in on my board like this. And this is the beauty of these solderless breadboards. I can just drop components on, start constructing my circuit, and quickly find whether or not it's going to work. So here we go. I don't have a 12 volt load or even a 12 volt supply that we can test that it's going to work. So instead of that, what I'm going to do, I'm going to just quickly look in my parts bin here. I should have some LEDs. I'm sure I got LEDs here somewhere. I better have some LEDs here. There they are. Okay. So the LED is going to be an indicator. What should we use? Let's use a green LED, shall we? Here's a green LED. We're going to use a green LED to symbolize that our device is being triggered. And we'll know that it's working. So now we've got to construct our circuit. And the first thing that we need to understand is, how do we use the MOSFET? So we live in the information age. So what we're going to do is what any good makers would be good at, and that's to do a search. Let's go to Google and let's find the data sheet for our MOSFET. Okay, so what did we say our MOSFET's serial number was? I've forgotten. Does it say on this package? It probably doesn't. No. And have I got eyes good enough to see this without the microscope? Let's see. It's IRLZ. IRLZ 34. N. Datasheet. Right, okay, here we go. Have a look what this datasheet has got to say for us. Okay, so description, 5th generation FETs. Whatever that means. Right. It's in a TO220 package. That's going to be important for us later when we start designing the circuit. Let's have a look at what we got. Have we got a reference circuit here? Okay, so here's a reference circuit. So it looks like our trigger comes in from this pin here. And then this pin is our source voltage, and this pin goes to ground. Okay, so let's have a quick look at... So we've got a gate. So the gate is what we trigger the MOSFET or transistor on. The drain is connected to... So it's draining through, right? It's draining our 5 volts or 12 volts, whatever our voltage is, down to source, which will be ground. Okay. So I need a pinout of our device so I know on our package which pin refers to which leg is which. Okay, I think that's here. Let's zoom in on this section. Okay, so we've got pin 1, pin 2, pin 3. Pin 1 is on the left-hand side. Interesting. Pin 4 is also like the heatsink. Okay, good to know. That's actually really good to know, especially if we need a... if we need to create a copper plate, if you like, to act as a heatsink. Because this thing could get pretty hefty, right? This MOSFET can handle up to 30 amps. That's a lot. 30 amps DC. This lighting system only needs 2 amps per light. So we're going to have 1 module per light. There's tons of headroom. This thing should not get warm. Okay, so pin 1 is the gate. Pin 2 is the drain. Pin 3 is the source. Okay? So I'm going to take a quick screenshot of that because no doubt I will forget. So I'm using the Windows snipping tool. Quickly take a snip of that, and that can go off up there, and we can come back to that as and when we need it. Okay? So I think I've got everything that I need to know in regards to that. But let's have a look at the Wemos D1 Mini. Okay, and we want a pin out. Let's have a look at this reference. Here we go. All right, so there's certain pins that we want to use. There's certain pins that we do not want to use. So things like our reset button, our transmit and receive, we want to avoid those. If we were to add some like display equipment, whether that's an LCD or LED, we might want to avoid things like this serial clock and serial data line. And also you've got these, I think they're I2C. These I2C, these might be I2Cs and these might be SPI. So there's certain pins in our designated jobs in hardware that when you're building a complicated project, you might want to consider whether you use them or not, because it might pen you into a particular configuration later on down the line. For us, it doesn't really matter, okay? So I think for the purposes of this, we're going to go, let me see, we'll use GPIO 5, 4, 0, and 2. That's right, because we were going to use multiple. We're going to use multiple MOSFETs in the design, right? No worries, Rubab. Appreciate it. So we're now going to go over to... I'm going to leave this on screen as I work, and we're going to go over to this and over our overhead. And we're going to start wiring things up. So the first thing we need to wire up is... Where did I put my jumpers? That would always help if I got my jumpers. Trying to wire a circuit with no jumpers is somewhat problematic. Okay. So I'm going to break out my goggles here because my eyes suck. I've got a set of magnifiers that will help me look a complete and utter idiot. But this idiot will be able to see. Look like the guy off Trailer Park. Right. Okay. So what do we want here? So for the purposes of this, I'm going to be using the 3.3 volt line to control my LED. So I'm going to run 3.3 volts up to my positive rail, which is just here. And we'll power this predominantly over USB. Okay, so that's... all we're doing is just running a jumper wire to these two locations, and this board essentially allows me to wire this very, very quickly. While I'm at this, I'm going to remove... have I got a set of tweezers here? I do not. I need a set of tweezers. One moment, please. So yeah, I'm going to remove some of the wiring that's already on this board because I've been doing some prototyping with another microcontroller. So what we're going to do is we're just going to quickly grab my tweezers. There's some teeny tiny wires that I need to remove. I don't mind the ground wire being there, but this voltage wire I just want to pull out because I don't particularly want to power up that circuit unnecessarily. All right, so we've got 3.3 volts going to our live. Now we need to tie our grounds in, and I believe that pin there is ground. It is. So let's use a grey wire for my ground. Okay. Make sure that I'm actually plugging it into the right place. So I'm going to just bring that out a little bit. And then we're just going to drop it into position there. And that gives us our grounds. So we've got power and ground to our to the board's rails. The board's rails are connected underneath. So what are we doing with this project? So for those of you who are watching, Rhubarb over on Twitch is asking, can you give us a quick rebrief on what this project is doing? So I have got some lights that I've got set up here in the workshop. I've got a key light here, and I've got a fill light just here, and I've got my main light just above me. This is on a DIY lighting control system that I built way back when I wrote the firmware for it. And essentially what it does is it switches 12 volt mains. Sorry, 12 volt mains? That even doesn't make any sense. It switches live mains, 240 mains is what I meant to say. I've got a set of sockets up here on the ceiling that my lights are plugged into. And I've got cables that trail down from those over to each of the respective lights. It hooks up into my home assistant, so I can use a dashboard to turn these lights on and off. And I have got a Node-RED setup, which then hooks these lights up into my Amazon Speak product, which I'll talk to in a moment. It allows me to control the light with my voice like this. Alexa, turn streaming lights off. Okay. Alexa, turn streaming lights on. Okay. So that's all well and good, but this current setup means that I've got these ugly wires trailing across my ceiling. It means I'm switching mains voltage. So depending on my lights, the brightness settings on these lights are set differently. And when the power goes out, you probably noticed the light didn't switch off exactly the same time. And that's because when the power gets cut from the mains, there is residual power in the power supplies that needs to drain down. One drains quicker than the other because the light is brighter than the other. And finally, the cables trailing from the sockets down to the lights is actually quite unsightly. So what I need to do is to build something which doesn't switch mains voltage. It runs off the power supply itself and can switch up to 4 devices on and off, given that they are running from the same voltage range. So it's essentially going to do what we just saw, but it's going to be in a nice, neat package. It's going to fit inside of a battery. I'm going to build a fake battery that will house the circuitry, and essentially will slot in the back, and it will have a series of buttons. This is going to be able to control up to 4 devices. It's going to have a local on-off button on the back here. So that's ultimately what this project is going to do. I hope that makes logical sense. If you've got any more questions, Rhubarb, feel free to ask away. So we're using a MOSFET capable of handling 30 amps. It's a bit overkill for this project, but you know, it does give quite a bit of range in terms of the applications for this device. The circuit board, I'm going to be using KiCad to do the circuit board design. And I'm also going to have these boards manufactured so that I can sell them on my website. If anybody wants to use this in their own setup, they absolutely can. We'll come into the software a little bit later, but I'm not sure how far through this process we're going to get tonight. And ultimately, we're live streaming this because we are waiting for components to arrive for the Lumen PMP. The Lumen PMP is a pick and place machine that I'm building, and essentially is a robot that will pick up components and place them on circuit boards so I don't have to. That might sound really lazy, but ultimately it means that I can put circuits together way faster and with less error than I can do by hand, which is quite important if you're going to be doing batch runs of circuits, which I do have the delight of having to do. It's a fun problem to have, right? Well, this is it, Rhubarb. It's better. So Rhubarb says it's better to have overpowered than run on limit and melt. That's exactly right. It also means that this device has a wide range of applications. I'm only using it currently for switching my lights. If I design this right, it will be able to be used for really low voltage devices, like 3.3 volt devices. Possibly lower. It could also be used for 20, 30 volt devices in theory, providing that my power delivery system for the ESP8266, as long as the power delivery has that voltage tolerance, then it can be used for quite a wide range of applications. And 30 amps DC there's not to be sniffed at, right? That's quite a lot. Right. Okay. So let's start getting wiring this out. So what I want to do is wire. Let me see. Let me get my diagram back. So we said the drain goes to 5 volts. So that's what we're going to do. Okay, so let's put the drain to 5 volts. Drain is pin 2. So let me grab a wire that we can grab, place on here. I'm going to put it down naturally where it wants to go. And then I'm going to move the MOSFET so that it sits. In fact, that is perfect. I don't need to move anything. Awesome. Okay. So that positive line is going to come through the MOSFET and is going to come down to the positive side of my LED. Now, because I'm using 3.3 volts, I don't need to use a resistor on this LED. So that's really helpful. So let's put my LED right there. Okay. Like so. And then I'm going to take a ground wire. Choose the blue for ground. Hoping that's slightly longer. It is. So we'll put it there, and then we'll put my LED. Hey, easy fella. Wants to go walkies. Now I need to make sure my LED is orientated correctly. There is a flat side to the LED indicating the negative side. So let's plop that in there with the flat side showing there. Perfect. And now we need to put a wire from one of the digital pins over to the trigger of the MOSFET. So let's use a gray wire. And we're going to use digital pin 1 here for this example. I'm going to just wrap this round. In fact, that's way too long. That is way too long, and that's going to be horrible looking. Let's not do that. Don't even get me started, Rhubarb. So Rhubarb is joking. He wants me to get the Wallace and Gromit esque alarm clock to make my tea and fry the bacon and all that sort of good stuff. So in terms of the base circuit, we're pretty much done. So we have a trigger wire to the MOSFET. We have our power on grounds wire to the power on ground of the overall board. We have power coming to the drain of the MOSFET. And then we have the output of the MOSFET going to the LED, which then goes to ground. Okay, so that completes the circuit. In reality, the LED will be replaced by a wire with a jack on it that will go into the back of my lights, delivering voltage into my lights directly, right? So let's power this up and look to program it. That means I need a micro USB cable to start with, and this is a blank board. And now what we're going to do, there is quite handily, there is a firmware available for multiple devices like the WeMOS D1 Mini, the ESP8266, the ESP32, called Tasmota. And what you can do, you load the firmware onto the microcontroller, and that then allows you to configure it so that you can control it. So what color have I gone for? It's a green LED. It is a green LED. If that's not coming out very well, I apologize. Right, so let's go to a browser source a moment. Let's find the Tasmota. So there's the Tasmota website. If I copy this a moment, I need to jump into Chrome. I typically use Brave. But if I come to Chrome, what we can actually do is we can actually flash the firmware from the browser itself. We don't even need any special programming software like Arduino or anything like that. We can program it directly from here. I was really impressed this week to see the standard satellite interfaces are using USB-C also. Yeah, that's right. Right. Yeah. Right. Okay. So what we got to find here? Getting started. We got a programming. Firmware builds. Let's firmware builds. Okay. So these are the bin files. Getting started. It's probably a good place to start. Scroll through. Says you need programmers. Blah 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 blah. Tasmota web installer. Awesome. Right. So now we're going to hook up our USB cable. And hopefully the stream stays up. If the stream goes bye-bye, I did something wrong. Okay? That means I've shorted something out. My computer doesn't like it. Here we go. Here goes nothing. All right. So we've now powered it up a blank ESP 8266. Let's go to... There's lots in here, right? So which Tasmota do we need? That is the ultimate question. I'm not entirely sure. So we're going to find out. We're going to find out. I've noticed audio has stopped. All right. So connect the ESP device to your computer using USB serial. You select the firmware variant suitable for your device. Hit install. Set the correct port. However, right. So we're gonna go with. These are developmental versions. Tasmota sensors. Let's try that one. Okay. Which device are we going to need to program? We got communication port 1, USB 2, COM 10, Bluetooth, factory. All right. I don't actually know. So what we're going to do, I'm going to unplug the device. See what disappears. So 10 disappears. So it's going to be 10 that we're going to program. So we're going to connect. Install Tasmota sensors. We want to erase the device and click install. Now, hopefully I've done this right. Here we go. I mean, what's the worst that could happen? I suppose I could brick it. In all fairness, I can probably recover it if I do brick it. All right. So it is installing. So when it boots up, it's going to create a Wi-Fi network, which we're going to need to connect to in order to program it with my Wi-Fi settings. Once it's done that, it'll reboot, and we'll then be able to fine-tune its configuration. No, I mean, that's half the fun, right? These are quite inexpensive. So much so that me building a circuit might be considered a little bit of overkill. But I like doing this stuff. And it means that... oh, it wants me to enter my credentials. Right, so let me do this. I'm going to just jump here. I'm going to see if I can... I'm going to configure my Wi-Fi using this tool, but I don't want to share my details on stream, right? So you can understand this. I know we're friends, but it's friends and then there's Wi-Fi sharing friends. Just saying. Okay, so it's configuring. Excellent. Excellent. It works straight out of the gates. Straight out of the gates. So here we are. We're going to do a configuration. We're going to configure the module. And we've got a bunch of GPIOs that we can select from. GPIO, we're going to say it is a switch. Okay, so you've got a switch and a switch underscore N. I suspect that's negative. So what I'm hoping, I think this is an N-channel MOSFET, which means we need a positive supply to trigger it, I think. And if we save that configuration, we go to the main menu. It's restarting. It's restarting. Come on. Show me. If I toggle this on and off, what we should hopefully see is that my green LED turns on and off. If I've done this right. If I haven't, nothing will happen. So let's see if I've done this right. In 3, 2, 1. No! It doesn't toggle. Dang it. Right, okay. Let's just see whether or not... where is my multimeter? We're going to use a multimeter and see whether we actually got voltage coming out of the pin. And this is the perfect time to say about, you know, this, if I built a circuit already, this would have failed, right? What's the problem? What is the problem that we're trying to solve right now? So first and foremost, we're trying to solve, do we have power coming out of my ESP8266? I have no idea. Let's figure that out. So we've gone to voltage. Pop that there so you guys can see. I'm going to put my connection on ground over here. And I'm going to just touch here, and we should get somewhere in the region of 3 volts if this is on. So this is currently off. And we've got 0.12 millivolts. Okay. So if I'm going to toggle it to on, so this should now be giving us some voltage. And our survey says, nil point. Okay. Well, that's less than desirable, right? So let us see what voltages we do actually have. So do I have 3.3 volts coming off here? We don't. Why don't we? Now, I wonder if the fact that I've got... I wonder if the fact that I've got this module is raised. It's actually pitched. I wonder if it's broken the connection of my voltages and grounds. Ah, hang on. One moment, Paula. Okay, let's just power down. I think I might have just spotted a problem. Yes! Yes! I've spotted a problem. My 3.3 volt wire is not connected to the correct pin. Like a doofus. Okay. Let's boot this back up. Okay, so we've now got power backup to the main module through the USB. Are we getting power to... Till I get a crate joint more soldering? No. Not worried about my soldering. Not yet, anyway. Nothing to suggest that. Right, so first and foremost, do I have power on my 3.3 volt on the board? I do. Do I get it on my jumper wire? I do. Do I get it here? I do. Do I get it over here on the leg of the MOSFET? Yes, I do. Perfect. So now, let's see whether or not I can toggle. Still get nothing, right? So let's see if I'm getting voltages off here. I'm not getting anything off this pin. So let's just go into the configuration. Configure the module. GPIO 1. Let's make sure that I'm actually plugged into GPIO 1. This is the beauty. This is the beauty of... No, I'm not plugged into GPIO 1. I'm plugged into GPIO 5. That would be my problem. Okay, so none. And I don't have a GPIO 5 on this list. This firmware doesn't give me access to GPIO 5. It's fine. What have we got? We'll go to the next pin. So let's power this down, because I don't want to short anything. Get a new board. Well, I was trying to move relatively quickly on this, right? It's not to say that's not without its problems. Okay, there we go. So we're now on GPIO 4, I believe. Let me just double check my drawings here. Yeah, I'm on GPIO 4. So if I go to here, right, and we go to GPIO 4, we say it is a switch. We save the configuration. Oh, that would help. Trying to save a configuration to a board that's not connected. Grr. Right. I'm hoping switch is the right thing to choose, right? But anyway, let's see whether or not I've got the right thing going on here. Is it switch or a button? Is it an input or is it an output? Ooh, gosh, I don't know. Anywho, what do we got coming out here? There we go. There we go. All right. So when I go here to my ground, I got 3.3 volts. So I think this is an N channel, so maybe I need to invert the switch. Right, so this is off, in the off state. And we got 3 volts there. What have I done? What on earth have I done? Okay. So, and if I toggle this, We still got 3 volts. That makes no sense. Okay, I'm going to remove the MOSFET. What have I done something pretty dumb here. Ah, thanks. Okay. I'm not getting the result I'm expecting, so I think I might be using this wrong. So let's go to the firmware. What do we need to use? Okay, I'm going to choose LED for a moment. I want to see this toggle. That's all I want at the moment. Okay, so we're now toggling. I see that toggling. So that's what we want. Good. So I'm going to reinsert the MOSFET, taking care not to short anything out. Okay, what do we got here? Huh. This is interesting. Two volts. No, not back to front. It's not back to front. It is doing what it's supposed to be doing to some extent. Right, so I'm fault finding, so I'm not necessarily the best at articulating what I'm seeing here. So let me get on the right scene to start with. So we're toggling our device. At the moment, it is in an off state. So when I place my probe on here, we're getting 3 volts, 3.3 volts there. And the output here, we're getting 2.1 volts, not 3.3. So let's check the data sheet. Let's check the data sheet for this MOSFET. It's supposed to be a logic level. I'm hoping it's not a 5-volt logic level shifter, because that would suck. Where are you? Not you. So you can go. Right, so go back to this data sheet. Just scroll up to the top for the specifications. I purchased this with the logic level in mind, so I'm expecting the trigger to be 3.3 volts. Gate threshold voltage is minimum 1 volt, maximum 2 volts. So is that what we expect? Is it triggering and there's some inductance going on, meaning that we're getting a loss? Is that what's going on? Right, I'm going to switch out the 3.3 volts to a 5 volt supply trigger. Not a trigger, delivery. So let's go. This is 5 volts. So there, that shouldn't impact us in any way, shape, or form for our current setup. Let's plug that back in. We don't want to plug the LED in because we don't have a resistor to protect current draw on the LED. So, right. So I've just put in the 3 volt line was over here. I've now switched it over. So it's now, this is now switching 5 volts. I want to see what this is doing in terms of the voltage trigger. At the moment, we got 2.1 volts. Let me see. Huh. Have I got this MOSFET wired right? Have I got it? Maybe I got it backwards. Maybe. Let's think about this logically, right? So that's the trigger. Maybe I need the... Maybe I need the output of the MOSFET to go to ground. Let's pull that out there. Right? And let's wire the MOSFET to ground. Gotta jump a wire, jump around. That's way too long. This is why having a good understanding of electronics is useful. Okay. Yeah. It's all right. I'm just contemplating how I'm doing this. So that's to ground, right? Now, if I put the LED in place with the ground pin towards my drain, be that way round, we'll need to power this down. Let me power this down a moment. I know, right? That's exactly what I thought. Jump around. Right, so negative to that pin there, and now reach across to positive, which currently is 5.5 volts. So if I just trigger this now, it's not going to be happy with me, right? So let's pull out the 5 volts and switch it back to 3.3. I think the MOSFET needs to be on the negative side of the circuit. So it needs to be, triggering the ground as opposed to triggering the live. I think that's how, well, that's my current logic. I could be completely wrong. We're about to find out. Oh, I saw something. Did you guys... We got an LED. We got an LED. Okay, it's inverted. It's inverted. No resistor. Doesn't require a resistor because we are driving 3.3 volts. So it's inverted. So let's go to our configuration, configure the module, and let's go to LED I, which I suspect is that reversed? My meter just turning itself off. Don't know what you mean. Okay, so that is inverted right there. So it's about finding. I'm gonna just put this as a switch negative, maybe. It's an N-type MOSFET. Right, what do I need? Relay? Relay? Relay. Imagine it's a relay. Yeah, there we go. That's better. That's better. So how are we triggering this? Let's have a look. This is an N-type MOSFET that we're using. And if I go here, we have 0 volts currently on the trigger of the MOSFET. And then when we hit the toggle, we now get 3.2 volts going there, and we get an illuminated LED. Okay. Okay. So that gives us the main prototype, right? We just need to repeat that process for all of the other channels, of which there's going to be 4. So I'm not going to delve too much into that right now, because we've proven the concept that this kind of works, right? What we do need to do is find a firmware version that allows me to add 4 of these channels. What I think I probably will also do is I will put an LED in line with all of this. In fact, let's see if I can do that. This is going to be how I'm intending on hooking up my... This is how I intend on hooking up the... not the button, but the... Think, Steve. The indicator, right? So I'm going to use a red LED. I'm going to just power this down a moment. I'm going to take the jumper wire out. And because this is logic level, we can pretty much get away with this. I can put the negative side of the LED towards the MOSFET trigger, and the other towards my pin for triggering, and I can't see a dang thing. Into D2. There we go, like so. Okay, so if I've done this right, what will happen is that the LED here will be my indicator when a particular channel is in operation, and this represents the channel in operation, right? So this would be my LED light, and this will be the indicator on the back of the module. So let's have a look to see if this is happy. No, they will be in a sequence, and they'll be numbered on a case, right? So that's not a massive problem. So if I now toggle, right, so that's interesting. That's unexpected behavior. So there's voltage going through here, but not sufficient enough to trigger my LED. Ah, okay. And it's some sort of capacitance. So that's not going to work. I'm glad I tested that. So I'll need to prototype that. A bit further to find out how I can get the LEDs to work the way I want them to. No, if it was back to front, it wouldn't allow voltage to pass through to trigger the MOSFET. It's enough voltage going through to trigger the MOSFET, but not enough voltage to drive the LED. So if I trigger this now, that's working fine. All right, so the next thing that we need to do, we need to set up so that this this setup will work on my Amazon voice thingy madoobry, right? So let's bring up my configuration for that. So this is my control platform for my lights. I can turn off these components. So if I go in here, it tells me I've got the Alexa home node configuration, right? So I need to add a new device. So let's do that. I gotta remember how I did this. Let me find. It's been a while since I've done this. Blah 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 blah. Okay. There we go. So in this web page, we're going to create a new device. Add device. We're going to call this device Attic. Yeah, just call it LED for now. It has an on, it's an off, it is a light. And then we click on OK. Name description. Okay, so this is LED test. We click on OK. All right, we come back to Node Red. And let us add a new Alexa Home. It's now wanting to talk to me. So let's choose that one. Let's refresh this, and we should find LED test in here. There it is, LED. Done. It is done. Right. Let's pick up our MQTT output. Oh. And let's call this LED, Attic LED. Done. Deploy. Now we got to tell the Tasmota to listen on the MQTT channel LED. So just for awareness, so what Tasmota does, it connects to a MQTT broker. The MQTT broker is a server that is almost like a chat room that can be set up on the fly. You can have devices set to broadcast on a particular channel, and you can also have devices listen in. So my Node Red installation is now going to broadcast on my Attic LED channel, it's going to say, hey, turn on, hey, turn off. The Tasmota is going to, I need to tell it that this channel exists. So let's go and do that. Let's have a look. So let's go back here. So we're going to go into the configuration, configure MQTT. We need the host. Right, okay. So host. So I put my host in. Password's not required. Client. We'll worry about this later. So we'll call this LED. How do we type it in this one? Cancel. Lowercase LED. Right. So this needs to be LED. Oh shoot, LED. And then it's prefix. Have we got a prefix? Host, port, client, user, password, topic, and then it's going to be attic /LED. We click save. That should now be listening in the right channel. All right. So now, if I just grab, I'm gonna grab these like injects. These are like little buttons. So I can just hardwire into this and just see whether or not my LED turns on or off. Right. So I hit deploy, confirm deployment. Okay, so we're good. I'm hoping when I click this button that our unit turns on and off, and currently it doesn't do a dang thing. That's irritating. I think I might need to check my conservatory light to see how I configured that, because I can't remember off the top of my head how I did this. So let's double check, shall we? Okay. Alrighty. So first and foremost, I need to find the IP address of my conservatory light. That's what I'm going to do right now. I'm just jumping into my. I'm just jumping into. Just looking at my client lists. There it is. Okay, 1.22. So if I copy. No. If I copy. This is my conservatory light. Connection refused. Well, that's handy. Is that right? Is that the correct? Well, dang it. Doubt it's HTTPS, but let's just check this Tasmota. Not secure. No, it's literally the IP. What we got here? Yeah, just literally the IP. It's there. I can see it, but I don't think I've got any other Tasm. Oh, actually, what about the attic light? Is that Tasmota? I don't know, or is it my firmware? I can't remember. Well, that's unfortunate. Okay, it might be that we need to go to our Tasmota documentation. That's probably a good place to start, right? Let's have a look. Tasmota. MQTT, right, okay. Prefix. What's the prefix? So full topic definition, modify it if you want to use the multi-level topics for your device. For example, light/prefix/topic. Ah! Dang it. Okay. I think I know what I did. Configuration, configure MQTT. It's that, right? Okay. Maybe now. Maybe now. Yes. Okay. So that's that. Does it work with my node red? No. What? That's irritating. Okay, let's see if Home Assistant can find it. Maybe Home Assistant can do what we can't hear. This is the joys of trying to do something live, right? So... Okay, so this is my Home Assistant. And if I go to media, no, settings, devices, Tasmota, 2 devices. Ooh. Okay. So we found it. We found it. And not only did we find it, if I toggle in here, We got the LED going. Okay. So I now got to figure out how I can turn this on, right? 4 entities not shown. Can I configure it? So Home Assistant can see it, which is good. So if I come back, Wi-Fi connect count on SSID. So I got to figure out how I can talk to this. So let me just quickly check something with the other Tasmota device that I've got. Which is this one, a generic. Huh. Okay. Yeah, quite possibly. Kaiserus is saying, can you check your MQTT logs to see what it's saying? Possibly? He's not shown. Add dashboard. Hang on. Hang on one darn second. Settings. Automations. Fill lights. Off, fill lights on. When an MQTT message has been received, turn on active lights. I need to create an MQTT trigger. You do it! Welcome in the stream, buddy. How you doing? Long time no speak. Hope you're well. Who's your daddy? Right, okay. So, I need to create an automation here, right? So, we're going to create a new automation. And we're going to add a trigger. MQTT topic. Oh, here we go. Here we go. Right, so it's attic/LED. Payload is true. Action, device, reload. Tasmota. Oh, is it Tasmota? Yeah, don't forget to like the stream on YouTube. So we're live streaming on Twitch and YouTube tonight. And if you're watching on YouTube and or you're watching on the replay on YouTube and you're seeing me responding to questions that are not coming up in chat, the reason for that is I'm talking to somebody over on Twitch and vice versa. If somebody's on YouTube and I'm talking to them and people on Twitch are seeing me answering questions that are not coming up in chat, that's because I'm talking to somebody on YouTube. So you do it. I'm currently building my own lighting control system, and I'm using my method of failure. Fail fast and iterate the failure until it works. So we're building a light control system for these lights. I already have one, but it's very, how can I put it? It's what we like to call a kludge, right? It's all over the place. I hear it slow and fail fast, right? It currently works on a relay set that is switching live mains. The new system is going to switch 12 volts. And essentially, it's going to have 4 channels, and it will be able to switch up to 4 devices using a MOSFET. So ultimately, that's what we're doing here. Rapid iteration based on real-world testing, right? It didn't work, try something new. So I've got to get the action to the Tasmota device. So let me go back into Home Assistant here. Into settings, devices, Tasmota. Right, it says it's called itself a Sonoff Basic. Right, it thinks it's a Sonoff Basic device based upon the firmware. So have I got a Sonoff Basic device here? No, I don't. We got Tasmota, Steve's phone, Plex. That's got to be it. LED test. Now, I'm not expecting this to work, right? Test. Save. Message malformed. Integration not found. I've got 2 Tasmotas now. All right, that's a condition, so we don't want to do that. Let's get rid. All right, 1 trigger, 1 action. That's all we want. So something's not right here. So it's named Tasmota, so maybe I need to rename this so I can kind of configuration. Is that what it's called here? No, it's not. Bigger module. Okay, I think it's picking up its name from this, right? But can it play Doom? No. No. Okay. So that works, right? Tasmota turn the triggers. Right, Tasmota switch turn on. So is that where I'm going wrong? So trigger. MQTT topic is attic/LED. Payload is true. Action, reload. Device, Tasmota. And we got no actions coming up here, which is a problem. So I'm wondering if I've got something weird going on with my firmware. Because I don't see, so this attic light's there, right? If I can turn on attic lights. Yeah, these are all, right, okay, got it. That's off my firmware, right? So there's something wrong with my firmware. Okay, so let's go back to Tasmota and let's figure that out. So getting started, MQTT knowledge, hardware preparation, yes, yes, yes. All right, this is for a Tasmota device. This is Tasmotizer, right, blah, 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 blah. Right, okay, so let's see if we can put in English. Tasmota sensors. I think this is what I used before, right? Or did I use the development Tasmota for sensors? All right, let's try this. Okay, we don't see a COM port. There it is. Boop. Connect. Update Tasmota sensors. Install. Okay, so off that goes. Let's see whether or not it was my firmware being a bit of a pain in the butt. Hey, SWK, welcome in the chat. You think there's the one that's offline? I don't think so, because it wouldn't show up, right? There's actually 2 Tasmota devices on my network. Almost installed. Let's get us back to a working configuration here. No. Bugger. Bugger. Is it back up? Yeah, it's back up. All right, configure the module. Relay, Sonoff Basic 1. Okay. It's not really changed anything, does it? Let's see if a Home Assistant thinks anything different now. Where are you, Home Assistant? There you are. Okay, so if we go to settings, devices, Tasmota, it's Sonoff Basic. Okay, I can turn the LED on and off, right? So that works. Yeah, we'll soon work it out. Right, so if I go back to here and go to settings, automation, we say create new automation. Create new automation. Action. Right, so we got device, call service, choose condition, device event, if then, play media. All right, so it's got to be device, right? We've got to do something with a device. Attic lights, that's the current set of attic lights. We got my conservatory light, have text. Tasmota. Oh, there's two. Right, so this one, no action. Yeah, there we go. There we go. We want to turn on Tasmota. Add a trigger, MQTT, and the topic is going to be attic/LED. Payload is true. Okay, and we save. New automation. This is going to be LED on. Oh, save. Right. So if we go to, can we duplicate this? Duplicate. Perfect. When a message received false, we turn off Tasmota. Save. Ah, bugger, I called it new automation. Can I rename it? Rename. Yes, I can. LED off. Okay. Rename. Save. All right. Let me just stop the music. Alexa, search for devices. Okay, Alexa, just... I don't know if you guys can hear Alexa. Okay, so Alexa's now searching for those devices. Don't know if you guys can hear that, but noise cancelling may be playing a part. Right, okay. Waiting for the device to be found. Once it's found, we should be able to use voice commands to be able to trigger the device. Okay, so I don't know if you can... Okay, device has been found. Right, okay. So yeah, Cadurus just said that his Amazon speech device is currently searching for devices. That's hilarious. Okay, here we go. This might be a bit fun if you've got speechy devices in your homes, right? Alexa, turn LED on. Yes! Alexa, turn LED off. Oh. Right, okay. So what I should now be able to do is if I go into my Node-RED and I can just send true false commands directly from Node-RED, and the LED turns on and off. So what I'm doing here is I am triggering a Node-RED bit of functionality in order to give me this on and off option. I'm liking a lot. Right. So so where are we up to in terms of our project, right? Let's have a quick look at our objectives. So we haven't sorted out our power yet. We have only one device controlled, so we need to update the firmware so that we've got full control of all 4 ports. So I need to do a little bit of research around which firmware I need to use in order to control that. So that's absolutely fine. We've connected it to Home Assistant. We've successfully done that, and we've successfully set it up using a Amazon voice device. We have the ESP8266 MCU being used, so that's a big check there. We're using the MOSFET logic level shifter, so that's good. We do not have local controls just yet. We haven't designed the battery. So what we're going to be doing is we need to design a 3D model that represents the battery that we're going to be using for this project. So this is the battery off the LED lights, and we're going to make a 3D model of this. We're going to hollow it out, and we're going to make some placements for the LEDs, the buttons. We're going to fix it so that it sits inside here. At the bottom of the battery, we want an input jack from the transformer that drives the LEDs lights in here, and then we want an output lead coming out with a small jack on it to plug into our lights, and that's what's going to get switched, right? So this device is only going to be a 1-channel, but we're going to be designing up to a 4-channel device. So the board is going to be unpopulated for channels 2, 3, and 4, which is absolutely fine for the purposes of what we're doing here. Now, with that said, let's quickly jump back to our objectives. So we need an LED indicator. We've got to figure out how we're going to drive an LED indicator. We want to have the resulting PCB to be compatible with our Lumen PNP, which we're building, which means that we've got to include fiducials so that the optical system can calibrate where the circuit board exists or placed on the machine, and we can ultimately then start placing components. And hopefully we'll get to a board that people want to purchase, and that'll be made available on my website. So in fact, I'll tell you what I'm going to do. I'm going to add an additional action item here in the list, and that is going to be number 8. Make available on website. Cool. Right. Okay. So we're eating away through our objectives. We've got all but, let's see, we've got half our objectives complete. I think objective 2, control up to 4 devices. I think we're pretty much there because we've proven that the MOSFET configuration that we've got works. We just need to make sure that we can duplicate that across multiple pins. So absolutely fine with that, not a problem. So I'm almost at the verge of saying we've got 3 out of 4 objectives complete. It's the attributes that we need to get down to business on. So that will be for a future live stream, quote unquote, video. What's going to happen next? So I'm going to continue to work and do some research in the background so that when we come to this project again, we can actually move forward with it with a little bit more pace and a little bit more understanding, because we failed a lot through this process, which I think is really good to demonstrate that, you can go into a project knowing absolutely nothing and kind of muddle the way through it until you get a functional piece of hardware as a mock-up. And then once we've solidified that and we understand how it works, we can then start designing the final hardware that will turn into the PCB that will be the final product. So don't think that you have to be an expert to get started on a project, because I'm not an expert. I I've shown my process here on stream. I've been very open book about how I go about things. Many of my projects go this way. Many of my projects go through this iterative process to the point of being functional. That's what I did with my stream controller, which has an ESP32 module inside. This is a multi-threaded application. It's running an e-ink display, 2.13-inch e-ink display. And if I just reboot it here, you'll see it. You'll see its refresh. And yeah, I went through an iterative process. The previous versions of this didn't look as nice as this. Even though this doesn't look that nice, they were worse. But yeah, the PCB that we built looks really, really nice. I'm going to keep one of these for just for posterity reasons. I like to keep versions of my hardware just so I've got a memory of all of the things that I've achieved and how I got here as well. So that's what we're doing with Come on, camera. Come on, you can do it. A little camera that could. There we go. So yeah, we're going to do this process for this project until such time as we get a working set of electronics, and then that's going to be turned into a schematic, turned into a board layup, and then we're going to reach out to a board manufacturer, and we're going to get these made. We're going to assemble it, and then we're going to finish the project. You never know, we may even get the Lumen PNP up and running in and around that time, so we can actually run some jobs for board population. And to be fair, I never thought that I would be going down the road of building a pick and place machine for making electronics. It's a bit of a side quest recently. I've managed to make some prototypes. Those prototypes have had a batch of those sold, and we're now gearing up to make that first batch. That's all going to be done by hand. The Lumen's unlikely to be ready to complete that batch, maybe towards the end of that batch, possibly. But we'll make the circuit with the Lumen in mind so that when it does come online, that we can pretty much go and get that operational. So yeah, that's where we're at. The next live stream will be covering either the Lumen PNP or the next step in making this lighting control system. So if that's something that you want to follow along with, feel free to hit that follow button if you're watching on Twitch. And if you're watching on YouTube, hit that subscribe button. Trust me, all of the likes, the subscribes, all of those things on YouTube make a big difference to how my videos perform on the platform, and they really do make a difference. So if you're not already subscribed, why not hit that subscribe button? And I'm going to draw this stream to a conclusion. So until next time, have fun, be safe, and I will catch you in the next one. Bye-bye for now.